Okay, here's the thing about black holes, is that your students want to know about them. It's very exciting. It generates a lot of conversation, and you're going to spend some time talking about it. But the thing about black holes is it's very theoretical. It's all this weird stuff. You talk about spaghettification. You talk about time dilation, singularities, how space and time are warped, and how you could have wormholes. And students get very mind blown by this whole thing, and it's just crazy. So I'll try to do my best. Black holes, you have to understand, are a misnomer, much like the Big Bang Theory, in that it's a name that makes you think of something that it's not. It makes you think of this hole in space, and black holes are not that. Black holes form in a very specific situation. This is after a supermassive star blows up and then collapses in on itself so that the pressure is so great that it overcomes the repelling force inside atoms and crushes that object down to something that is infinitely dense. And we call this object in the interior of a black hole, it's called a singularity. It is an object in there. And that object has a tremendous amount of gravitational pull because it is so dense. It's so great that when light is emitted from this object, the gravitational force pulls it right back in to it. So black holes do not emit any light, which was one of the very difficult parts in actually trying to locate them. But what we are actually able to see them is by the effects that they have on space around them. And you can see some of those in this artist's drawing here. What you can see around here is what we call the accretion disk, swirling material around this before it gets plunged into the singularity itself. This, which you see here, is what we call a jet. And this is material ejected out at high rates of speed, very near the speed of light, as material is crushed into that singularity. Now, what happens in this case is that the black hole itself actually distorts space and time. And so we have what's called a gravity well leading down to that singularity. And objects that pass this certain point, which we call the event horizon, it's the point of no return. If you go over that, you are going to go in. You cannot escape the gravity of that black hole. If you stay out of it, you can stay out of it. But it doesn't matter how powerful your rocket is. If you go past the event horizon, you will go in. And then objects that go in, there is a tremendous amount of gravitational difference in these objects going in. So if it was a person, they would get extremely stretched out in this event before the black hole rips them apart and makes it part of them. This process here is called spaghettification. Now, objects going into a black hole are going to accelerate very near the speed of light. And as they get closer and closer to the speed of light, time moves slower for them. It seems normal for a person, but somebody observing it, like watching somebody go into the black hole, it will appear that they are going slower and slower and slower, when in reality for them, time goes normal and they get crushed into the black hole. So some of the effects and some of the myths that you need to be aware of. This time dilation I talked about, spaghettification I talked about. If a star collapses and becomes a black hole, the mass is the same. So one of the constant questions that you'll get is, oh, what happens if the sun becomes a black hole? Well, number one, it's not massive enough for that to happen. Number two, if it did, its mass wouldn't change. It'd just be taking up a much smaller area. So the planets would still orbit it. They wouldn't be sucked in. And then the other thing is that students think that black holes are like these space vacuums. They just fly around in space and suck everything up. Well, black holes generally stay in place. And if something gets too close to them, then the gravity will pull them in. There is more astrophysical theory involved around these, whether it's Stephen Hawking or Albert Einstein or any other scientist talking about this, that things could happen. One of the things that they talk about is wormholes or time travel. And it's a possibility, but the problem is you're talking about being accelerated to near the speed of light as you go into the black hole and somehow missing the singularity. Wormholes are the linking of these two areas where if you had two black holes, you could link these wormholes on opposite sides and potentially travel through here, and you would be traveling a massive distance through space in only a very short distance between these two. This could be meters, but you could be traveling thousands of light years across space. But what's the problem is right here in the middle is this darn singularity. How do you get around that? Now, if you have more questions about this stuff, I know it's very, very weird. I know this was very fast, me going through it here, but you have to be somewhat familiar with this.